let's look at what is a data type. So what is data types? What is user defined data type? And what is abstract data type? So to understand it, first we need to understand the data. So data is the epicenter of everything. So let's say if I write in this way, int num is equal to 10. So here int is a data type, num is a variable, and 10 is the data. So to store the data we are using a variable. So in this case it is num, and we are also defining based upon the type of data, so the data type of this variable. So in this case it is int. So there are some system defined data types, which are also known as a primitive data types. So they are basically int, float, character, pointer, etc. So these are all the system defined, machine defined, so also known as a primitive data types. So okay, so int num is equal to 10. So this here int is known as data type. This is what we understood. So we can define it as this way. It defines a, so what is a data type means? It defines a certain domain of values and operations that are allowed on these values. So what we are saying is that, so for the data type there will be some data, and what are the operations that can be performed on the data. So what are the operations that can be performed on the data? So these two are the fundamental things that defines the data types. So let us see with an example. So earlier we understood that with int is a data type, and it stores only integer values. It is system defined. So system defines that by using the int data type, it should be only storing the integer type of values in whatever the variable we have taken, and it allows the operations. So what are the operations that are allowed? So on the int data type is addition operation. We can do subtraction, multiplication, addition operation example, let's say 4 and 2 we get 6. And we also can do bitwise operators. So bitwise and, let's say 4 and 2. So what does it mean? So 4 means 1 0 0 1 0 0. This is 4, this is 2. So what will be the output? The output is 0 0 0. So the output of 4 and 2 will be 0. So bitwise and, so for bitwise and the output will be bitwise and the output will be 0. So like this we can also do the bitwise operators on the integer, but we can't do the bitwise operator of course on the float. It is not possible. So basically for a particular data type, what is the data and what are the operations that are allowed. Coming to user defined data types. So these are basically not the system generated. Let's say we can understand with example. So struct employee. So this here employee is the, so here struct. So the examples of it will be using like struct, enum, union. So these are the most popular user defined data types. So here we are using an example of struct. So here employee is the variable, struct is the data type. In user defined data types we will be having a summation of different data types. So in struct employee we can have like integer, let's say employee id, let's say float employee salary, and let's say char name. So these are all the different, so these are all again the primitive data types or the or the machine defined data types only. So using them all together is known as user defined data type. So we are using various primitive data types as per our advantage. So this way. So this is the user defined data types. So here we can say, we can define it is in this way. So here the operations and the data are not specified in language, but rather are user defined. Whereas in primitive data types, here the operation and data are defined in the, are specified in the language, are defined by the machine. So that is thing. The third thing is abstract data types. So they are kind of like user defined data types, but not exactly user defined data types. So it will also having some values, and also it can also perform some operations on these values or data with help of functions. So this is the broad definition. So it is also, they are like the user defined data types which defines the operations allowed on the values with help of the functions. So if we take example of stack, it is an abstract data type. Stack abstract data type. If you take example of it, so we can have data in it, we can do operations on this data, but how we are doing these operations is with the help of the functions. Here in stack we have two functions majorly which we are using, push function and pop function. So we can say like this: abstract data types are set of operations. So we use these operations but don't know their exact implementation. That is implementation details are hidden. So simply primitive data types, we have next seen user defined data types, next we have seen abstract data types. Here in all these cases we will be having the data and we can do some operations on it. So here data and operations, here they are basically in primitive data types, they are basically the system defined, whereas in user defined data types, here the data type is defined by the user based upon their customization need. It is also like similar to array, but in array we store same data types, store data, multiple data, store multiple data of same data type. Whereas in user defined data types like structure, we store data, multiple data of different data types like int, float, character, so pointer. So different system generated primitive data types, we will be using it in the user defined data types. There is an abstract data types, we will be having the data and we can do some operations on it, but these are done based upon by the use of functions. So we don't know the background or a back end of implementation of these, but we'll be using these abstract data types. Example stack, we can implement it with the help of arrays, linked list. So this is broadly about the data types, primitive data types, user defined data types, and abstract data types. Coming to examples of abstract data types, we have the stack, then we have queue. So basically stack follows last in first out, whereas queue follows first in first out. And then we have trees, and then we have graphs, etc., hashing, all those things. So these are the examples of abstract data types.